So we've looked at the edit mesh and how we can make polygons up from vertices and how we can connect those vertices together to create edges. And when we have three edges, we have a polygon. We also know about other features of meshes in 3ds Max, such as smoothing groups and also material IDs. In this chapter, we're going to look at the edit poly and how it differs both in theoretical terms and also in practice from the edit mesh. Internally, the edit poly is a much more complex polygon type than the edit mesh. For a start, it can actually represent true polygons. By that I mean that a polygon in the edit poly can have any number of sides or edges, as long as it's 3 and up. It can't actually have a polygon with just 2 sides because that would be, a line. So it has to have at least 3 edges to be classed as a polygon. So you can have tripolygons, quadrilateral polygons, pentagonal polygons, hexagonal polygons, so on and so on. So let me show you with these two objects that you can see here, the difference between the two. If I click this object, you can see it's an editable mesh, and you can see that this object in it is an editable poly. And these are just planes that I've converted into their object types just by using the right click convert to menu option. And if we click on the edit mesh and go into subobject mode, edge, you can see that I've selected all the edges here, and you can see if I actually just make these visible, you can see that we have triangles making up this object. And I'm sure you're very familiar with this from the previous chapters in this DVD. This object is made up of triangles. There's no getting away from that. And that's all the edit mesh can actually do. Now, if I go out of subobject mode and I have a look at the edit poly here, and let's go into edge mode. Again, I've got all the edges selected, and you can see that there aren't any triangular polygons in this mesh. So straight away you can see that we have quite a big difference between the edit mesh and the edit poly. We have true polygons in the edit poly. Now in this case we've got 4-sided polygons, but it's actually very easy with an edit poly to create polygons with many more sides. And you can do something with edit poly that you can't actually do with edit mesh, which is if we select an edge here, and if I press delete, it deletes the edge itself and also the polygons which are associated with it. And this is normal behavior. This is the kind of thing you'd expect from an edit mesh. So I'm just going to undo that, press Ctrl Z. And what I'm going to do now is I'm going to press backspace on the keyboard instead of delete. And you can see that we've actually kept our polygon. And instead of it actually deleting the polygon, instead what it's done is it's removed the edge. It's changed 2 polygons into 1. So if I go to the polygon subobject type and click on it, you can see that it's just an entire polygon there. Now, if I grab this vertex and pull it out, as you can see, we have a polygon with 1, 2, 3, 4, 5, 6 sides. So we have a hexagonal polygon here, basically. As you can see, we have 6 sides to it. I'll just undo that. And if we go back into edge mode again, I can select this edge, press backspace, and if I do backspace here, as you can see, it has to remove the other edge because you can't have that edge orphaned in the middle of the polygon. If we look at vertices, you can see that we still have, let's see, 8 vertices. They still remain. So we have a lot of edges now to this object. And so pull these out if I need to. But we can actually delete those edges. If we press delete, we lose the vertex and also the face attached to it is destroyed. But if we press backspace, again, it removes the vertex but doesn't actually destroy the geometry around it. Where we had 2 edges, we now have 1 edge. And I can get this vertex and do the same here, and the same here. And now we are back to a polygon with just 4 sides to it again. So we're back to a 4-sided polygon. If we try to do the same things with the edit mesh, as you know from the previous chapter, it would actually delete some or large amounts of the geometry. If we went in and we selected here and we just chose vertex and press delete, well, we're going to lose the vertex and all the edges which are based on it. And if I press backspace, it doesn't actually work. So you can see that the ability to remove geometry and have the mesh reconfigure itself into different polygon types is a feature that you only get in the edit poly mesh. With the kind of freedom that you've just seen here in terms of modeling, there also come a number of limitations with the edit poly. There are a lot more rules in edit poly than there are with edit mesh. As an example, a polygon in an edit poly cannot have a hole in it. If we go over here and we let's get these edges here, we'll just make those invisible. And now we appear to have these polygons, but we know that in fact the faces are still there. So if we select one face and we press delete, well, we can have a hole in it. Well, you can't actually do that with the edit poly. You can't actually select one of the polygons, one of the triangles that makes up a face and delete it. It will actually delete the entire polygon. You can't actually have a hole in a polygon. It has to be a complete set of boundary edges and then a polygon inside it. Another feature of the edit poly is that neighboring faces need to have unified normals. And what that means is that the normal which you find on the vertex between two edges has to be pointing in the same direction. It can't point in two different directions. So again, that's another limitation or feature of the edit poly. And another big limitation, and also a blessing in a way, is that polygons in an edit poly can only share one edge. You can't have an edge with 4 or 5 polygons coming off it. The last limitation actually gives the architecture its name, as it's often referred to as being the winged edge architecture. And the term winged edge is used meaning that each edge in the mesh knows what 2 polygons are used by it, which 2 polygons actually come off that edge. And the same edge also knows what the other edges are connected to, and this also goes for vertices too. So let's take a look at this diagram, and it may make it a little clearer as to why the phrase winged edged is used with this particular architecture. Okay, so if we look at this diagram, you can see that we have a number of elements, so I'll just explain what they are. The letters, which go from A to E, they represent the edges of our structure. Then we have the polygons themselves, and they are numbered 1 and 2. And then we have the vertices that we can see here. So you can see we've got a very simple data structure here. We just have 2 vertices, which are lettered X and Y. We have an edge that goes between them, edge A, and then we can see that coming off edge A we have 2 polygons, 1 and 2. Then there's actually a little bit more data which is stored along with this, and what that is actually the order in which the edges adjacent to the edge in question, edge A, are structured. So for instance, on polygon 1 we have B preceding the edge, and we have D succeeding the edge, and then on polygon 2 we have E preceding the edge and C succeeding the edge. And what that means is that if we look at polygon 1, we go B, A, D, and that travels in a clockwise direction. And as we saw earlier, that's very important for defining the normal. So that's why it actually flows in that direction. And if we go over to polygon 2, you can find that you've got the same flow of direction again. It goes E, A, and then C. And as you can see, if you look at the diagram, it gives you the rough impression of there being a winged object, like a butterfly or something like that. So that's why we call the polygon structure for this particular system the winged edge structure. And if you look at the URL that I've listed below, you can actually find a much fuller explanation of this architecture, and you can see fully why the winged edged architecture gives you the ability to find out where any vertex is that neighbors your edge, or what edges are opposite your current edge. And it basically allows you to traverse the mesh very quickly and find out all the geometry that lies in the area, and allows you to basically carry out a subdivision workflow in a very efficient manner. So in the edit poly, because of the data structure that we've just looked at, the mesh system can be said to be smart. What I mean by smart is that it has a kind of knowledge of the other mesh elements that branch from and surround it. The advantage of this knowledge is that it's very easy in programming terms to step from polygon to polygon or edge to edge with very little processing overhead whatsoever. And this means that the edit poly mesh is much better suited to doing the kind of modeling that's needed for subdivision surfaces. Not only is it much better suited, but it produces much faster results. You can actually create tools that work much, much faster than they ever would with an edit mesh. And for that reason, the winged edged architecture has become the standard mesh definition for pretty much most packages these days. That's enough for the theory anyway, so let's move on now and take a look at edit poly and how it differs from edit mesh in its makeup. Some of the differences will be obvious based on what I've just explained about the eMesh and the ePoly architectures. Others will not be so obvious. So let's have a look at some of these now. So firstly, I need a new edit poly object. So I'm going to get this object here, hold on shift, drag over here and leave go. It's going to make me a copy. Now, because these edges are hidden on the edit mesh, we know that they're there, but we know that they are actually hidden at this moment. When we convert it into an editable poly, you'll see that those edges don't appear. Now, if they were visible, they would actually appear, and the reason for that is that the edit poly can actually have three-sided polygons, so it could basically reconstruct the data that you have of here pretty closely. In other words, we can end up with a tri-mesh. But because those edges are hidden, it just basically treats these as quad polygons, so we end up with quad polygons. So I'm just going to do some quick modeling here. Just drag this out. And we just need some more geometry to actually show you some of the features that I'm going to talk about here. That gives you the kind of extrusion that you can see here. There we go. So I'm just going to grab all the edges and move it up here and here. That lines up with our little label here. And we can get rid of the edit mesh for now, I think. So let's look at some of the sub-objects of the edit poly. And I'll just drag this panel out here again and once more, because we need a lot of space actually with the rollout for the edit poly. It has a lot of different options in there. Now, let me just do this. So there you go. There are all of the different rollouts. Now, firstly, we have vertices, and we're pretty much familiar with these from the edit mesh. As you can see, we have a bunch of different vertices here. And then we have edges, which connect the vertices together. And when they connect together, they produce polygons, which you can see here. We've got multiple polygons on this object. Well, we have elements also, and those are pretty much familiar to you from the edit mesh. They have the same kind of functionality. They record objects that used to be separate, and therefore you can actually select them once again and detach them and so on, and make selection of these elements much easier when you're in sub-object mode. But we have a new geometry type, and that's called border. If I just click on that and click here, this is one border, which you can see is basically a group of edges which do not have polygons on the other side of them, as it were. As you can see, you've got a polygon here, but you haven't got a polygon on this side. Now, if I click on this edge here, you can see it doesn't do anything whatsoever. But if we make a hole in the mesh, let me just select one of these polygons and press delete. Now, if I go to border and I select this edge, you can see it actually selects that for me. So borders are, as I said, edges with only one polygon on them. And they may not seem to be that useful, but they are very useful, because sometimes when you're modeling, you might make a hole in the object, and there's a feature here called cap. What it allows you to do is to actually take a group of edges that basically form a continuous border, and then if you click on cap, it'll actually fill that border in for you. So if you have a hole in your mesh and you want to fill it in, you can actually just use border to select the edges of that hole, and then when you have those edges selected, you can just press cap and you can fill in the hole. So that's actually a very useful modeling feature.